P427 introduces the concept of a 20-ton group with sufficient, I'm going to describe it as accumulated provenance, to make it highly likely that the members of that group are one and the same. Now, as individual attributes, it might be said that that evidence or that provenance is not compelling. But when all these attributes are satisfied at the same time, I think it should offer reassurance that the members of the group are the same material. So those attributes of accumulated provenance are the source, the same building, the function, the size, and the similar building, similar detailing. And when all those things are all in agreement, the conclusion should be that we have reasonable confidence that they belong to the same group. P427 describes identical detailing, and some have taken that to mean absolutely identical, that even a different bolt hole or a cleat means that something is not identical. That wasn't the intent, and that will be clarified in the next revision of the document. So having assembled some provenance to establish that we think all these members are the member of a group, then there are non-destructive tests to reassure us that the grouping was correct. And then there is at least one destructive test to reassure us that the non-destructive tests were telling us the correct story. And I suggest that's kind of layer upon layer, and hopefully that will provide us the necessary confidence in the steelwork. Now, it's really obvious that we're going to be recovering steel which is not perfect. It may not be feasible or safe to dismantle members in a structure in an entirely perfect way which retains their original condition. Demolition contractors are likely to shear steel and likely to burn through steel members. Demolition contractors may not treat the steel gently and lay it out carefully. So as well as the damage during demolition, there may be additional damage as well. There may be other issues, dashes, gashes, dents, maybe some deliberate holes which were there for services, for example. But those imperfections may have no significance at all in the new structure. And in my opinion, it's derelict to assume that if we ask for a new building or part of a new building to be constructed from reused steel, which of course is a very good ambition, we must recognize that there will be some additional effort. So we must have to consider the proposed sections and decide whether those proposed sections, with their imperfections, whatever they are appropriate. We have to consider whether any holes make any impact or not. We have to assess whether any damage is significant or not. These are structural issues. They need structural engineering input, and that probably means that our clients need to be educated to pay for that additional structural engineering input. So, when a beam is recovered, it will probably be burnt. After 50 years, bolts are generally unwilling to come out. That's not a concern to me, because I think during fabrication, those ends will generally be cut off. I think it's extremely likely that a new building could reuse a building without, reuse a member, I should say, without any fabrication at all. And so the engineer will have to assess the importance of the importance of the particular features. Maybe even significant holes are not significant structurally, depending on where they are. So as I say, I think clients will need to be educated that if reused steel is to be incorporated into their structure so that they can demonstrate they're meeting their moral or their legal targets, there is some work, and consequently there is cost, and that needs to be covered. But it needs to be presented that the value is seen in a reduced carbon solution, and that's absolutely the right way forward. Even seriously damaged members can have a second life if they're cut into shorter parts. Even things like beams with shear studs welded on them, well, maybe they could be used upside down, for example. I appreciate in all this there are fabrication issues. It's going to be more difficult to fabricate a beam which has got old shear studs on it to get it through the numerically controlled machinery. But it's not a showstopper. It can be done. That's the point. So I mentioned earlier that I think plasticity has been taken too literally. And I appreciate that some damage to a flange tip, for example, could be described as plastic damage since the material has been deformed. But the intent was plastic hinges. And in my view, as I've explained, I think we're very unlikely to see them. I don't believe that the exclusion of steel recovered from bridges to avoid anything which has experienced fatigue is a particular problem. I suppose the background of P427 was that we would primarily be recovering steel from buildings. One thing which is expected of the stockist is to examine tolerance. So there is a tolerance on the cross section and there is an important tolerance on the straightness. And I know that some stockists have installed extremely clever machinery to examine the straightness of members about both axes. Straightness is particularly important, of course, when we design a member. We are allowing for an initial lack of straightness, and the assumption is based at least in part that the member satisfies the straightness criteria. Any worse than that, and the member would have to be straightened or discarded.